Okay, so page 19 of the Passport to Advanced Mathematics, we have just a short little section we're going to do on solving polynomial equations, and then we're going to move on to our last function we're going to learn for this course, and that's going to be rational functions. Okay, so we know how to solve linear equations, we know how to solve exponential equations, we just learned how to solve quadratic equations, and now we're going to learn how to solve polynomial equations. Okay, it says when solving polynomial equations, simplify the equation first. If it cannot be factored, then we can only solve by graphing. So this is how we started with quadratic equations. We would simplify first, get everything to one side. We would see if we could factor it. If we couldn't factor it, then we would use the quadratic formula. Now for polynomial equations, if we can't factor it, then we have to use our graphing calculator. Okay, so it says examples, solve the following polynomial equations. Okay, so first of all, let's get everything to one side, and we will see if we can factor. So I'm just going to bring the 4x and the minus 6x cubed to this side. So I'm going to subtract 4x, add 6x cubed. So I'm going to have 6x cubed minus 4x minus 8x squared plus 4x squared minus 20x, and then we have equals 0 over here. Now I'm going to simplify here. So 6x cubed, this would be, these two can be together, so minus 4x squared minus 24x equals 0. I think that's correct. Okay, so now I'm going to see if I can factor this. I can take a, looks like a 4x, no, a 2x out. So this is 3x squared, this would be minus 2x minus 8 equals 0. Let me just look and see if this is quadratic now, if we can factor that, which I don't, no, that one does not factor. Okay, so this is one that we're going to have to plug into our calculator. You can plug any three of these into your calculator. Okay, I'm going to choose the middle one. I feel like this is the easiest one to type in. It doesn't matter which one you choose though. Okay, so get out your calculator. Okay, we're graphing both sides of the equation. So go to y equals, we'll do 6x cubed minus 4x squared minus 24x. And we also need to graph the other side of the equation, which is 0. Okay, window. Let's just do standard and see if it works. And let's graph. Okay, so this first graph will be our polynomial, the 6x cubed minus 4x squared minus 24x. Looks like we need to make the window higher. Okay, and then there's x equals 0. I mean y equals 0. So remember when we just have a number, so if this was 10, it would have been up here at 10. Let's just go ahead and make it y maximum larger. Let's try 50. And y minimum, let's try negative 50. Let's see if that gives us a better, oops, I must have plugged in the wrong thing. Has to finish graphing. Sorry. Okay, this needs to be negative 50 to negative 50. Y minimum negative 50, y maximum just 50. That should work now. See, I have a little dot here. I should have turned off my scatter plot. Okay. There, that gives us a good picture of that polynomial. And it looks like there's our x equals 0. Alright, so we should be able to just use our intersect feature. Notice that this factored form over here, you could do one solution. 2x equals 0, that means x equals 0. Okay, which looks like that's the solution here. Now we need these solutions, so where they intersect. So second, calculate, go down to intersect. I'm going to go hover around this left one first. It looks like x equals approximately negative 1.69 as a solution. I'm going to go ahead and write the x equals 0. We can see that one. And then we have one more. Okay, so I'm going to hover around that intersection point. And it looks like x is about 2.36. Okay, so there's our solutions for that one. Okay, number 2, we have x cubed minus 2x squared equals negative 8 plus 4x. Okay, again, I'm going to get everything on one side. So we'll have x cubed minus 2x squared minus 4x plus 8, and then we have equals 0 here. Okay, I'm going to try to factor this. We can't take anything out of the whole thing, but I can factor first 2, second 2. So the first 2 I could take an x squared out. That would give us x minus 2. The second 2 I could take out a minus 4, and that would give us x minus 2. Okay, now out of the whole thing, we could take out an x minus 2. So the first term, that would leave us x squared. The second term, it would leave us minus 4. And now we can factor this. This is a quadratic. We're looking for two numbers that multiply to negative 4, add to 0. Since there's no middle term here, that would be negative 2 and positive 2. Okay, so now because of the zero product rule, we can set each one of these equal to 0. So x minus 2 equals 0, and we have x plus 2 equals 0. We don't need to write the x minus 2 equals 0 again. So our solutions would be x equals 2 and x equals negative 2. And you can check that in your calculator also. Okay, and then the very last one, 4x cubed minus 10x squared plus x equals 9. Okay, we'll try to factor first. I don't believe this one factors just by looking at it. We could take a 2x out here. No, that's not going to factor. So let's go ahead and graph this. So we'll have 4, oops, I need to move this over so I can see it. 4x cubed minus 10x squared plus x minus 9. And then we already have 0 here already. Let's go ahead and change back to standard window, which this may not work. No. So I need to, it looks like I need to make the y minimum larger. Okay, so you can see that we need to finish that graph there. So I'm going to do y minimum, let's do negative 50. See if that works. Okay, so there's our polynomial. Yes, that gives us a good picture. And there is x equals 0. And it looks like we just have one solution here. Okay, so you can see that it intersects just there. So second, we want to go to intersect. Okay, second curve. And it looks like x is about 2.71. Alright, so that ends polynomial functions, polynomial equations. So now we're going to move on to our very last type of function. This is rational functions. Okay, again with rational functions, you're not going to be expected to graph them, but you do need to recognize what a rational function looks like, and you also need to be able to pick out asymptotes. I also want you to be able to pick out domains. So we're just going to go through this. When we get to the graphing portion of it, I'll use my calculator and then just go through some terms with you. But you do need to know, especially domain, vertical asymptotes, x-intercept, y-intercept, and then we'll look at a horizontal asymptote as well. Okay, so definition, a rational function is a function of the form r of x equals p of x divided by q of x, where p and q are polynomial functions. We assume that the polynomials p of x and q of x have no factor in common. Okay, so to have a rational function, you need an x in your denominator. Okay, so for example, f of x equals 10 over x. That's a rational function, okay, because you have an x in the denominator. It says consider the function f of x equals 4x plus 8
over x plus 3. Okay, that x in the denominator, that x plus 3 in the denominator makes it a rational function. 1a, it says find the domain of the function. So we know how to do this. Remember, when we find domains, we're looking for two things. We're looking for fractions or even roots. Well, we have a fraction, so we know in fractions the denominator can't be 0. So we're going to write that. So remember, this is how we did domains. So we're going to write the denominator can't be 0. Okay, so that means that x can't be negative 3. Okay, so I just got x by itself. Okay, so in a graph, you have x is negative 3 here. Okay, so here's x is 3. So in your graph, we know x can't be that. Okay, so I'm going to put a horizontal line there. I'm sorry, a vertical dotted line there. Okay, so that means the graph can't cross this in any way because x can't be that. Okay, that gives us a vertical asymptote. Okay, so it says there are vertical asymptotes at, we just have one, x equals negative 3. So at negative 3, we're going to draw this vertical line. The graph can't cross this in any way. It can get really, really close to it, but it can't cross it. Number 2, it says find and plot the x-intercept. Okay, so the x-intercept is where y equals 0, or where it crosses the x-axis. Okay, so we're looking for a point somewhere here. Okay, so we want to set the whole function f of x equal to 0. So 0 equals 4x plus 8 over x plus 3. Now a fraction is 0 when the numerator is 0. So we really can get rid of that denominator. So we have 0 equals 4x plus 8. Okay, so now solving, I'm going to come over here. That would give us 4x equals negative 8, so x equals negative 2. So our x-intercept would be negative 2, 0. Now our y-intercept, number 3, that's when x equals 0. So we're just going to plug in f of 0 here. That is 4 times 0 plus 8 over 0 plus 3. That would be 8/3. Okay, which is, as a fraction, is 2 2/3. Okay, so our y-intercept would be 0, 2 2/3. So that's where it crosses the y-axis. Okay, bottom of page 20, it says determine the end behavior by the leading term. Fill in the blanks below and draw the horizontal asymptote on your graph. Okay, so 4, and I believe we'll have number 5 on the next page. I'm going to go ahead and graph this, and then we're going to fill in 4 and 5. Okay, so on to page 21. I'm going to go ahead and graph this here with my calculator. Then we're going to look at the horizontal asymptote, that was number 4, and we're also going to look at this here, what's happening here. Okay, so getting out your graphing calculator, we're going to graph, which I need to look back at my function. A rational function we need to always put in parentheses, which we have talked about this. So put the numerator in parentheses, put the denominator in parentheses always when you're using your calculator. We can get rid of the 0. And I believe standard window will work, which we almost have standard here. Okay, and graph this. I'm just going to copy this graph. Okay, so this is a rational function. Most rational functions look like this. There's normally 2, 3, even 4 pieces of a rational function. Okay, so you have 2 pieces here. Okay, so graphing this, we know a couple things. We know that at negative 3, there's a vertical asymptote that came from our domain. We also had a x-intercept at negative 2, 0. So we had this point here. And we also had a y-intercept at 0, 2 2/3. Okay, and I'm just copying this picture now, filling in those specific points. Okay, it looks like the picture that the calculator gave us is this. Okay, something like this up here. Okay, so we have a vertical asymptote here. Okay, it looks like we have, if you look back at this graph, it's a little more accurate. We have a horizontal asymptote here. Okay, so let's look at our horizontal asymptote. That's going to be as x goes to infinity. Okay, what's happening here? Okay, it's approaching something but never actually reaching it. So if you look, it looks like it is approaching around 3 or 4 maybe, we can't really tell. So if we look at the leading term, and this is number 4, so I'm going to look back to page 20. Okay, it says determine the end behavior by the leading term. So the leading term is, remember leading terms of polynomial, is the term with the highest power. So the leading term of the numerator is 4x. The leading term of the denominator is x. Okay, so the leading term of the whole thing would be 4. Okay, this is our horizontal asymptote. Okay, so let's look and make sure that makes sense on the graph. Okay, so at 4, we have a horizontal asymptote here, which I need to erase this because it can't cross this here either. Okay, so that can always be determined by the leading term. Okay, so on the SAT, you'll probably be given a picture, something like this, and it'll say what's the horizontal asymptote, okay, what's the vertical asymptote, where's the y-intercept, where's the x-intercept. You also might have something like this. It says as x goes to -3, this plus sign means from the right, what's happening to y, and as x goes to -3, this would be from the left, what's happening to y. Okay, so let's just look at this. As x approaches -3 from the right, so as we're going to -3 from the right, your y goes way down here. Okay, as you get closer and closer to -3, it drops. So this would be -infinity. And as x goes to -3 from the left, it's way up here, it's actually going to positive infinity. Okay, so you might have to answer something like that. So given a graph, be able to answer these questions. So as x goes to infinity, what's happening to y? Which let's go ahead and write that. As x goes to infinity, so as you travel to infinity, y is going to 4. Okay, that's your horizontal asymptote. It's never going to cross 4 here. As x goes to -infinity, so as you move out this way, again, y is going to 4. Okay, so make sure you can answer questions like that on rational functions. Again, you're not going to have to graph these, but you will need to know asymptotes. Okay, middle of page 21, we're going to just go on to simplifying rational expressions. You will have these on the SAT. You'll have some simplifying, multiplying, dividing, adding, subtracting. Okay, so it says to multiply, divide, add, and subtract rational expressions, follow the rules for multiplying, dividing, adding, and subtracting fractions. Okay, so let's just quickly go over those. If you have 1/2 times 3/4, okay, remember you just multiply across. This would be 3/8. If you have 1/2 divided by 3/4, that's the same as multiplying the reciprocal. So it would be 1/2 times 4/3. That would be 4/6, okay, which you could simplify to 2/3. Okay, so this is the same thing when you have variables. Okay, so number 1 says x over y times 2x squared over y. So we're going to multiply here. This gives us 2x cubed, we're just multiplying straight across, over y squared. Okay, so that's all you have to do when you multiply rational expressions. Number 2, we have 4xy squared over 3y divided by 2x over 4y. Okay, first thing we need to do is flip the second fraction. So we have 4xy squared over 3y times, now we have 4y over 2x. Okay, now you can go ahead and simplify here. So this would be by crossing. I always go ahead and multiply and then simplify. Okay, but you can go ahead and simplify out. So you would cancel the y here, cancel an x here. Okay, so this is multiplying across 16xy cubed over 6xy. Okay, now we can do some simplifying here. We would divide out by, it looks like just 2, so this would be 8 and 3. The x's completely go away. This y goes away. This would become just 2. So this is 8y squared over 3. Okay, this should be a review for you guys. Okay, page 22, we're just going to continue here. Number 3, we have 4 over 3x squared times x plus 5 over 4. Okay, so we need to clear this up. Multiply. This would be 4 times x plus
5, I'm going to not distribute yet, times 4 over 3x plus 1. Okay, the only thing that's going to cancel here is 4. So this would be x plus 5 over 3x plus 1. Okay, a really common mistake is you guys would cancel these x's. You cannot cancel that. It's part of an expression. Okay, so you have to leave the expressions alone. Okay, if on the denominator it was x plus 5, then you could cancel the x plus 5 and the x plus 5. Okay, but you can't cancel variables if they're part of an expression. Okay, and the last one of multiplying and dividing rational expressions is number 4. It's x plus 2 over 2x divided by x plus 2 over 9x squared. Okay, so we have divided by, so we're going to flip the second fraction and multiply. So this would be 9x squared over x plus 2. Okay, so we're left with 9x squared when we multiply times x plus 2 over 2x times x plus 2. Okay, so now we have expressions here that we can cancel. The 9 and the 2 we can't. We could take this x away. This would become 1 here. So we'd be left with 9x over 2. Okay, and then the last part we're looking at are adding and subtracting rational expressions, which these are much harder than multiplying and dividing. Okay, so we were adding 1/2 plus 3/4. Okay, we can't just add right across. We have to get like denominators. Okay, so we would multiply this fraction by 2. That would give us 2/4 plus 3/4. Then we add the numerators, keep the denominator. Okay, so that's exactly what we're going to do with expressions. Okay, so number 1, we have 1 over x plus 3 over y. Okay, we need to get a like denominator here. Okay, so I'm going to have the denominator be x times y. Okay, because we're going to take the x from this, the y from this. Okay, so the first fraction we need to multiply by y. The second fraction we need to multiply by x. So I'm sorry, y over y, x over x. Okay, why can we do this? Okay, if you notice, we are multiplying by 1. Y divided by y is 1, so we're not changing the expression in any way. Okay, we're just making it look different. X over x, okay, we're multiplying again by 1. We're not changing the expression. You don't change a number when you multiply by 1. It just looks different. Okay, so this first fraction will become 1 times y is y over xy. The second fraction will become 3x over xy. Okay, so notice this first fraction is still 1 over x, okay, because we could cancel out the y's. Okay, that's exactly why we did this. It did not change, it just looks different. Okay, so now we have like denominators, so we're going to add the numerators, y plus 3x, keep the denominator. We cannot cancel this. Remember, again, this is part of an expression, so you can't cancel the x and the y's. Okay, and that's our solution. There will be a couple like these on the SATs, so make sure you understand these. Okay, number 2, x over x minus 3 minus 4 over x. Okay, the denominator needs to be definitely x minus 3, it comes from the first fraction, and also times x from the second fraction. Okay, that means we need to multiply the first fraction by x over x. Again, we're multiplying by 1. The second fraction by x minus 3 over x minus 3. So again, by 1. Okay, so the first fraction becomes x squared over x times x minus 3. And the second fraction becomes 4 times x minus 3 over x times x minus 3. Okay, so we're subtracting here. I'm going to go ahead and just subtract the numerators. This is x squared minus 4 times x minus 3 over x times x minus 3. Let's go ahead and simplify this numerator. This becomes x squared minus 4x plus 12 over x times x minus 3. Now let's make sure this doesn't factor, because if there's an x minus 3 here, we could cancel. So we're looking for two numbers that multiply to 12, add to negative 4. So 12 is 1 and 12, 2 and 6. Does that work? No, because it's plus 12. Yeah, that wouldn't work.
3 and 4. Yeah, so this is as simple as we can make this one. Okay, number 3, same type of thing. So x plus 1 over x, this should be squared here. X squared plus 4x plus 3 plus 2x squared over x squared plus 5x plus 4. Okay, before we need to find the denominator, let's go ahead and factor those denominators. So we'll have x plus 1, can't do anything with that. This is multiplies to 3, add to 4. That would be x plus 3 times x plus 1 plus 2x squared over multiplies to 4, adds to 5. That would be x plus 4 times x plus 1. Okay, so our new denominator, we need an x plus 3 and an x plus 1 from the first fraction. Okay, from the second fraction, we need an x plus 4 and an x plus 1. We already have the x plus 1, so we just need the x plus 4. Okay, so our new denominator is going to be x plus 3 times x plus 1 times x plus 4. Alright, so our first fraction, we're going to multiply by what we're missing in the denominator, which is an x plus 4. So x plus 4 times, over x plus 4. And then our second fraction, we're going to multiply by what we're missing, which is the x plus 3. So x plus 3 over x plus 3. Okay, so this first fraction becomes x plus 4 over x plus 1. Our denominator is x plus 4 times x plus 3 times x plus 1. Our second fraction is 2x squared times x plus 3 over x plus 4 times x plus 3 times x plus 1. Okay, so now we have the same denominators, so we can just add the numerators. X plus 4 times x plus 1 plus 2x squared times x plus 3 all over x plus 4 times x plus 3 times x plus 1. Okay, so we've ran out of room. I'm going to stop there. We could make this look a little simpler. Okay, we would have to distribute this, so this would become x squared plus 5x plus 4 plus 2x cubed plus 6x squared. So the numerator would become looks like a cubic polynomial. Okay, we're just going to leave this alone. Okay, I know you guys know how to simplify that. Page 23, we just have a couple more. So number 4, we're going to do subtraction, and then number 5, we'll do division, and we have addition, part 2. Okay, number 4, it's 3 over x minus 3 minus 2 over x squared minus 4x plus 3. Okay, so we're going to factor again, just because we have a quadratic here. So 3 over x minus 3 minus 2 over, so this is multiplies to 3, adds to negative 4. That would be x minus 3 times x minus 1. Okay, so our new denominator needs to be x minus 3 from the first fraction, and then we also need an x minus 1 from the second fraction. Okay, so on the first fraction, we need to multiply by x minus 1, since that's what we're missing. So we'll have 3 times x minus 1 over x minus 1 times x minus 3. We're not missing anything in the denominator from the second fraction. Okay, so we're just going to copy that. There's no reason to change that. Okay, so now we can go ahead and subtract. I'm going to go ahead and distribute this. This is 3x minus 3. So this is 3x minus 3 minus 2 over x minus 1 times x minus 3. So this becomes 3x minus 5. Yes, over x minus 1 times x minus 3. Okay, and I believe that is as simple as that can get, because we can't factor that. Okay, and we have one more, number 5. We have 1 divided by 1 divided by x plus 2 plus 1 divided by x minus 2. Okay, so we're going to simplify this first, okay, by adding, and then we're going to plug it back in. Okay, be careful with these. I've seen a couple of these on the SATs. they will put just the solution to this denominator, but don't remember it's part of a larger fraction. Okay, so make sure you plug it back in. Okay, so we're going to go ahead and do this first. So 1 over x plus 2 plus 1 over x minus 2. Okay, the denominator here needs to be x plus 2 from the first fraction times x minus 2 from the second fraction. Okay, so first fraction we need to multiply by x minus 2 over x minus 2. So that gives us x minus 2 for x minus 2 times x plus 2. Now the second fraction we need to multiply by x plus 2 over x plus 2. So that gives us x plus 2 over x minus 2 times x plus 2. Okay, so now we can add. This gives us x minus 2 plus x plus 2 over x minus 2 times x plus 2. Okay, this would simplify to, actually I'm going to just go down here. This simplifies to 2x, because the minus 2 plus 2 goes away, over x minus 2 times x plus 2. Okay, this is not the solution. Remember, we have to plug it back into our division problem. Okay, so I'm going to come down here. I'm running out of room. So we have 1 divided by 2x over x minus 2 times x plus 2. Okay, because I'm plugging this back in to the original problem. Okay, remember what you do with division. You just flip the second fraction. So we have 1 divided by this, so that's actually multiply by the reciprocal here. So x minus 2 times x plus 2 over 2x. Okay, when you multiply that by 1, that just gives you x minus 2 times x plus 2 divided by 2x. And there's your solution. Okay, I've seen a couple on the SAT that look almost exactly like this, so make sure you understand this problem. Okay, so you'll go ahead and stop there. You'll practice set 4. This is on polynomial functions and rational functions. Then you're going to go ahead and practice set 5. This is on scatter plots. There's a lot of scatter plots on your SAT. These will be over linear functions, exponential functions, quadratic functions. There might be a couple polynomial functions on there. And these are all on scatter plots. Practice set 5 is scatter plots. So you should be able to do practice sets 1 through 5 now. Okay, and that concludes the Passport to Advanced Math